Yes, here we are again. Continues. In order to settle once and for all the question of the existence or the non-existence of the ether, the American scientists Michelson and Morley in the middle 80s of the last century, that would be the 19th century, that'd be the 1800s, yeah, began a whole series of experiments assisted by special apparatus invented by themselves. The apparatus was mounted on a stone slab fixed upon a wooden float revolving in a tank filled with mercury and made one full revolution in 6 minutes. A ray of light from a special lamp fell on mirrors attached to the revolving float and partly passed through them and partly was reflected, one half going in the direction of the movement of the earth and the other at right angles to it. This means that in accordance with the plan of the experiment, one half of the ray moved with the normal speed of light and the other with the speed of light plus the speed of the rotation of the earth. At the union of the divided ray, there should have appeared, according to the plan of the experiment, certain light phenomena resulting from a difference in speed and showing the relative movement between the earth and the ether, that is, indirectly proving the existence of the ether. Observations were made over a long period at all times of the day and night, and nothing was discovered. From the standpoint of the original problem, it was necessary to recognize that the experiment failed, but it disclosed another phenomenon, possibly much more significant than that which it attempted to establish. This was the fact that the speed of a ray of light cannot be increased. The ray of light moving with the earth differed in no way from the ray of light moving at right angles to the direction of the movement of the earth in its orbit. Or is it that it does increase in speed, just that our perception cannot realize it? It doesn't actually say that there. This is just me adding it. Anyway. It was necessary to recognize as a law that the velocity of a ray of light is a constant and limiting quantity which cannot be increased. And this, in its turn, explained why Doppler's principle was inapplicable to phenomena of light. At the same time, it established the fact that the general law of the composition of velocities, which was the basis of mechanics, could not be applied to the velocity of light. Right. In his book on relativity, Professor Einstein explains that if we imagine a train moving at the rate of 30 kilometers a second, i.e. with the velocity of the movement of the earth, and a ray of light overtaking or meeting it, then the composition of velocities will in this case be impossible. The velocity of light will not be increased by the addition to it of the velocity of the train and will not be decreased by the subtraction from it of the velocity of the train. At the same time, it was established that no existing instruments or means of observation can intercept a moving ray. In other words, it is never possible to catch the end of a ray which has not yet reached its destination. In theory, we may speak of rays which have not yet reached a certain point, but in practice we are unable to observe such rays. Consequently, for us, with our means of observation, the propagation of light is virtually instantaneous. Kind of what I was saying before. At the same time, the physicist who analyzed the results of the Michelson-Morley experiment explains its failure by the presence of new and unknown phenomena resulting from great velocities. The first attempts to solve this question were made by Lorentz and Fitzgerald. The experiment could not succeed, was Lorentz's formulation for his propositions. For every body moving in ether itself undergoes deformation. Namely, for an observer at rest, it contracts in the direction of the motion. Yeah? See what I was saying before? Basing his reasonings on the fundamental laws of mechanics and physics, he showed by means of a series of mathematical constructions that the Michelson-Morley installation necessarily suffered a contraction, and that the amount of the contraction was exactly such as to counterbalance the displacement of the light waves consequent upon their direction in space, and thus to annul the results of the difference in velocity of the two rays. Lorentz's conclusions as to the presumed contraction of a moving body gave rise in their turn to many explanations. One of these explanations put forward from the point of view of Professor Einstein's special principle of relativity. But this relates to the new physics. The old physics was indissolubly connected with the theory of vibrations. The new theory, which came to replace the mechanical theory of vibrations, was the theory of the atomic structure of light and electricity, taken as independently existing matters composed of quanta. The new teaching, says Professor Chwolson, appears to be a return to the Newtonian emission theory, although considerably altered. Or even altered. This new teaching is far from being completed, and its most important part, the quantum itself, still remains undefined. What a quantum is cannot be defined by new physics. The theory of the atomic structure of light and electricity entirely altered the view on electrical and light phenomena. Science has ceased to see the fundamental cause of electrical phenomena in special states of ether and has returned to the old doctrine which admitted electricity to be a kind of substance which has real existence. The same thing has happened with light. According to modern theories, light is a stream of minute particles rushing through space at the rate of 300,000 kilometers a second. They are not the corpuscles of Newton, but a special kind of matter energy formed by electromagnetic vortices. The materiality of the light stream was established by the experiments of Professor Lebedev of Moscow. Professor Lebedev proved that light has weight. That is to say that light, when falling on bodies, produces a mechanical pressure on them. It is characteristic that at the beginning of his experiments to determine the weight of light, Professor Lebedev based them on the theory of the vibrations of the ether. This shows how the old physics confuted itself. Yes? Professor Lebedev's discovery was very important for astronomy. For instance, it explained certain phenomena which had been observed, the passing of the tail of a comet near the sun. But it was chiefly important for physics as it supplied a further confirmation of the unity of the structure of radiant energy, the impossibility of proving the existence of the ether, the establishment of the limiting and constant velocity of light, new theories of light and electricity, and above all, the study of the structure of the atom indicated the most interesting lines of the development of the new physics. Another part of new physics was developed from that particular formation of physics which was called mathematical physics. According to the definition which was given to it, mathematical physics, yes, stay with me folks, usually started from some fact confirmed by experiment and expressing a certain orderly connection between phenomena. It enveloped this connection in a mathematical form and further, as it were, transformed itself almost into pure mathematics and began to elaborate exclusively by means of mathematical analysis those consequences which followed from the basic proposition. Thus, it is presumed that the success or unsuccess of the conclusions of mathematical physics might depend upon three factors. First, on the correctness of the definition of the fundamental fact. Second, on the correctness of its mathematical expression, and third, on the correctness of the subsequent mathematical analysis. All right. Professor Chalson writes, there was a time when the importance of mathematical physics was greatly exaggerated. It was expected that it was precisely mathematical physics which should have served the principal course of the development of physics as a science. This, however, is quite erroneous. In the deductions of the mathematical physics, there are a great number of essential defects. In the first place, in almost every case, it is only in the first rough approximation that they correspond with the results of direct observation. This is caused by the fact that the premises of mathematical physics can be considered sufficiently exact only within the narrowest limits. Moreover, these premises generally disregard a whole series of collateral circumstances, the influence of which, outside these narrow limits, cannot be neglected. Therefore, the deductions of mathematical physics correspond to ideal cases, which cannot be practically realized and are often far removed from actuality. And further, it should be added that the methods of mathematical physics make it possible to solve special problems in hardly any but the simplest cases, especially so far as the form of the body is concerned. But practical physics cannot limit itself to these cases and is continually faced with problems which mathematical physics is incapable of solving. Moreover, the results of the deductions of mathematical physics are often so complicated that their practical application proves to be impossible. In addition to this should be mentioned yet another very characteristic property of mathematical physics, namely that as a rule, its deductions cannot be formulated otherwise than mathematically, and lose all their meaning and importance if an attempt be made to interpret them in the language of facts. The language dependencies of the great thought systems of the West. You lot can't handle paradoxical logic, can you? The new physics which developed from mathematical physics possesses many of the properties of the latter. Einstein's theory of relativity is a separate chapter in a new physics which has developed from mathematical physics. Remember, folks, this was written in 1914. I can't believe what the fuck they were teaching me in school, Northolt High School, back in 1974. Anyway, Here we go. It is wrong to identify the theory of relativity with new physics as is done by some followers of Professor Einstein. New physics can exist without the theory of relativity, but for us, from the standpoint of the construction of a model of the universe, the theory of relativity is of great interest because it deals, before anything else, with the fundamental or even the fundamental question of the form of the universe. Interesting shit. Stay tuned.